All right, welcome back. Sorry about that. It only lets me record 15 minutes at a time. And I was having so much fun doing this linear regression that I didn't realize I was out of time. So, welcome back. Here's where you should be. So we have our X and our Y, list 1, list 2. And now, next we want to fill in this row where it says store the regression equation. So that just means, do you want to put the equation somewhere? And yes, we do. We want to put it in our y equals where it will graph, because then our line will be graphed right on top of the our scatter plot, which is exactly what we want. So to get that to happen, we want to press the vars key. Vars meaning variables. And then you want to arrow over to the right and click on Y vars, Y variables, and just press enter on Y1. So that means it's going to store the equation in our Y equals, where we graph. And that will be really great because then it will graph it as well. So let's press enter. Here we go, our first one ever. Awesome. So there's our equation. So let's go back to our note page. Here I am. And let's jump to part C, where it says to give the equation for the least squares regression line, rounding to 2 decimal places. Awesome. So let's go back to our calculator. Now, they use slightly different notation than us, but instead of A, we usually think of this as M. So that's our slope, and B stays the same. So to round to 2 decimal places, I want to look at my third decimal. So my slope is going to just be 0.59. I don't want to round up any because 4 is little, less than 5. And now for the y-intercept, I want to round my y-intercept to be negative 208.74 because that 5 in the third spot. So jot that down for part C. And let's get this equation together. So again, my slope was positive 0.6. Not 0.6, 0.59. 0.59. And my y-intercept was negative 208.64. 0.74. Let me double check. Sorry, I'm going between my paper and my calculator. Yep, 0.49. Okay, 0.59. Yeah, okay. All right, so let's finish this up here. So, negative 208.74. Awesome. So let's put it all together then. Y equals 0.59x plus negative 208.74. So that is the equation for my line of best fit. Now, since I stored that equation in the y equals, you'll see it show up if you click on y equals. So let me show you what I mean by that. There it is. So it does not round to 2 decimal places like we did. So it's going to be very exact, which is great. So there is the equation we just found. Now let's press graph. Excellent. So that is our line of best fit. So now on your paper, we want to sketch this line. So get out a straight edge, and we want to try to closely mimic that line. So take another look at it. Looks like it almost goes through this point here and these points down here. I'm going to get out my tool, but make sure you have a straight edge. So it looks like it goes through this point. And it's a little harder for me because I can't look right at it when I'm graphing it. Let's see how good I did. Ooh, that's not so bad. Okay, we'll take it. So we want to put that line of best fit on our graph. That's part B there. So we've got part B, part C. And now let's move on to part D. So for part D, how many points does this line of best fit predict for that player? So let's write our equation down one more time. So here's our equation, and he played this many minutes. Minutes is our x. So I plug that in here. Type that into your calculator. I'm actually not going to tell you what it is. You're going to have to type that one into your calculator, but make sure you label it points. And you might want to look back to your classwork on from Thursday, because this was the question letter F, and you predicted how many points Antonio would get then. Now, whatever answer you get here is more accurate. It's a better prediction. So it's more likely to be correct than your previous prediction, because now we have the best line of best fit. So type that into your calculator. Now let's interpret our slope in context. So this is very important. Maybe if you missed this one on your quiz, this is a great review. So what is our slope saying? Our slope is saying for every increase in x, for every increase in one x variable, whatever we're going up by in our x. In this case, it's minutes, right? So for every 1 minute played, that's the first part. The second is we predict. And now we put in our slope, 0.59, and then it's our y variable, which is points. So for every 1 minute played, we predict about 0.59 points scored. Now let's interpret the y-intercept. So our y-intercept was negative 208.74. Now let's interpret that. Our y-intercept is when x equals 0. So 0, what was our x again? It was minutes. So 0 minutes predicts negative points being scored. That doesn't make any sense. There's no way you can score negative points. This is not a good prediction. Bad prediction. The reason this is a bad prediction is because 0 is outside of our data. There's no one in our data list who actually scored 0 minutes or played 0 minutes. And so when you make a prediction for a value outside of your original data set, it's typically not going to be a very reliable prediction. This is a fancy word. It's called extrapolation. Extrapolation, I think I'm saying that correctly. You might learn about it in a future math or science course. Awesome, let's finish this up here. Could the line of best fit, or the least squares regression line, reasonably predict how many points were scored by players who played less than 350? All right, well, to do that, let's look back on our graph. Okay, so here's our graph. So for players who played less than 350 minutes, that's going to be players over here, right? Does Does our line predict? Is our line making very good predictions down there? No. The predictions are negative, right? So all of these predictions down here are negative point values, which is impossible. That is just not possible. So even though these data points are within our data set, because there's not many of them, our line of best fit is being pulled in another direction. And so even those predictions aren't always going to be accurate. So absolutely no, not possible to score negative points. That is not possible. So tying this back to our discussion on residuals, these would all have positive residuals, right? What actually happened was above the line, greater than the line. So their prediction was actually negative, and they scored a couple points. So that's good for them, right? But those predictions are not good. So not possible to score negative points. So these are not good predictions. So the line is only a prediction. It's not always going to be correct, right? It's only a prediction. So it will not always make the best predictions. The line is only a prediction, not always. So it's only a predictor, it's only a model. It might not always make the best predictions. And that we can tie that into some other discussions we've had in class, right? Like Giannis can't always improve 4 points per season for his points per game, right? At some point, Giannis is going to grow up and get a little older. So it's not always going to keep, our lines aren't always going to keep going in either direction. It's just a model. So I hope this was helpful in getting you set up for your line of best fit. You can look back on this video for help if you forgot how to do this. And your homework now at this point is 6.1.4, day 2. Have a fabulous rest of your day.